Unit step response of a unity feedback second order system. Here in this problem, the forward transfer function of the system is given, that is g of s equal to 25 divided by s into s plus 5. From the given open loop transfer function, we can draw the block diagram of the system. Here this is unity feedback system with negative feedback, so we can draw the block diagram like this. Its forward transfer function is g of s equal to 25 divided by s into s plus 5, input r of s and output c of s. So this is the block diagram. To find the overall transfer function of the system, we can apply the formula c of s divided by r of s equal to g of s divided by 1 plus g of s h of s. Here for unity feedback system, the value of h of s equal to 1. So we can substitute h of s equal to 1, then we can find c of s by r of s, which is equal to the given open loop transfer function divided by 1 plus open loop transfer function into h of s equal to 1. If we take LCM and cancel the numerator and denominator, finally we will be getting the simplified expression c of s divided by r of s. So the value of c of s divided by r of s is equal to 25 divided by s square plus 5s plus 25. So now we can compare this overall transfer function with the standard second order transfer function. The standard second order transfer function is c of s by r of s is equal to omega n square divided by s square plus 2 zeta omega n s plus omega n square. We can name this as equation number 2. If we compare equation number 1 and equation number 2, the omega n square value is equal to 25. We can find omega n, which is equal to 5. Now 2 zeta omega n is equal to 5. If we substitute the value of omega n, we will be getting the value zeta as 0.5. So now the value of omega n is 5 and zeta is equal to 0.5. Since the value of zeta is 0.5, which is between 0 and 1, the given system is underdamped system. Now we can find the roots of the characteristic equation. For underdamped system, the roots of the characteristic equation will be a distinct and complex value. So let us find the roots of the characteristic equation. Here the equation is s square plus 5s plus 25 equal to 0. So now we can apply the formula is equal to minus b plus or minus b square formula. If we substitute the values, we will be getting the value of s in complex number minus 5 plus or minus square root of 25 minus 10 divided by 2. If we take the square root and the minus term outside, we will be getting this complex number. So now the roots are complex and are distinct. To find the step response of the system, we have to substitute r of s equal to 1 divided by s. If we substitute the value of r of s, we will be getting c of s value in equation number 1. Here c of s equal to 1 divided by s into 25 divided by s square plus 5s plus 25. Now we have to apply partial fraction and then we have to take the inverse Laplace transform. To apply partial fraction, we can take a divided by s plus b divided by some constant, c by constant. Here it is complex roots, so we cannot apply this kind of partial fraction. We have to take this s square plus 5s and plus 25 as a whole, because it has complex roots. So we can apply the partial fraction like this: s by a by s plus bs plus c divided by s square plus 5s plus 25. Now we can number this equation as 3 and this one as 4. Now we can take the LCM of this right side equation. So we will be getting the common denominator. We can cancel the common denominator. So we will be getting one equation, that is 2s is equal to a into s square plus 5s plus 25 plus bs plus c into s. From this equation we have to find out the value of a, b and c. First let us compare the constant terms, then we will get 25 is equal to a into 25, so the value of a is 1. Next we can compare the coefficient of s, then we will be getting a into 5 plus c is equal to 0. So we can find the value of cs minus 5. Now we can compare the coefficient of s square, then we will be getting 0 is equal to a plus b. Now we can substitute the value of a, then we will be getting the value of bs minus 1. Now we know the value of a, b and c. We can substitute all these values in equation number 4. Then we will get c of s equal to 1 by s plus minus 1 into s plus minus 5 divided by s square plus 5s plus 25. Now to find out the inverse Laplace transform, we have to rearrange this equation. So the denominator we are going to represent it as s plus some constant the whole square. To convert this denominator into this form, we are going to add and subtract 5 divided by 2 the whole square, that is 2.5 square in the denominator. So we will be getting this equation as s plus 5 divided by square plus 5s plus 2.5 square minus 2.5 square plus 25. So now this first terms we can write it as s plus 2.5 the whole square. The remaining we will be getting minus 2.5 square plus 25. So we can write this as s plus 5 divided by this term. Now the numerator we have to split it into two parts. So this 5 we split as 5 by 2 plus 5 by 2, that is 2.5 plus 2.5. So we can write this as this form. So now in the numerator we have 2.5 term, and in the denominator also we have s plus 2.5 the whole square. This will be useful to help take the inverse Laplace transform. So we can group these terms together and we can group the second terms together. Then we will be getting s plus 2.5 divided by some s plus constant square plus some constant square. If we take root for 18.75, we will be getting 4.33. Then the second term will be getting some constant divided by constant square. So now we can apply inverse Laplace transform formulas. So first let us see the formulas we are going to use here to take the inverse Laplace transform. The Laplace transform of 1 is 1 by s. The Laplace transform of sin omega t is omega divided by s square plus omega square. Laplace transform of e power minus at into sin omega t is omega divided by s plus a the whole square plus omega square. Similarly, for Laplace transform of cos omega t is s divided by s square plus omega square. Laplace transform of e power minus at into cos omega t is s plus a divided by s plus a the whole square plus omega square. We are going to apply these formulas to take the inverse Laplace transform. So these two equations are in the same form and these two are in the same form, but in the numerator we don't have 4.3, so I am going to multiply and divide it by 4.3. So I will be getting the Laplace transform format. So now I can rearrange this equation. So I will be getting c of s equal to 1 by s minus s plus 2.5 divided by s plus 2.5 square plus 4.3 square. 2.5 divided by 4.33 into 4.33 divided by the terms. So we can easily apply Laplace transform here. So now we can take the inverse Laplace transform of this equation. So we will be getting C of t. Here it is 1 by s, so it is step. So 1 minus, now we are going to apply this cosine term. So e power minus 2.5t into cos of 4.33t as per the formula. Here if you do the calculation, here the value is 0.5774 into the sine term, e power minus 2.5t into sine of 4.33t. So now we got the inverse Laplace transform. From this equation we can take this e power minus 2.5t as outside. So we will be getting this equation. So here we have a constant term, e power negative term, and sine cosine term. If we plot this input and output relationship, here the input is step input, that is r of t, and the output is c of t. We will be getting an oscillatory output which is exponentially decreasing. So this is the graph for the equation c of t. Here we have the constant term, exponentially decaying term, and sine and cosine term. From examination point of view, we can stop the derivation here, but the output is having sinusoidal term, so we can combine this sine and cosine terms to form a single sine term. So let us rearrange this equation to get a single sine term with the phase shift theta. So we can write this equation as c of t is equal to this equation. Now we can compare this equation with sine a plus b formula. So if we write the formula for sine a plus b, we will be getting sine a cos b plus cos a sine b. So here this cos 4.33t can be compared with cos b, and here sine b. So from this we can find the value of b is equal to 4.33t, but we have the coefficient terms as 1 and 0.5774. Here we have sine a and cos a. If we find the square of these two values, we should get the value 1. Accordingly, we have to select the value of a in such a way that sine a square plus cos a square equal to 1. To get this value, we have to multiply and divide with this term, square root of 1 square plus 0.5774 square. So now we can rewrite this equation c of t as 1 minus e power minus 2.5t into multiply and divide by this term, square root of 1 plus 0.5774 square, and divided by the same term into cos 4.33t. Here also we are going to multiply and divide with the same term, so that we can select the correct value for a, which will satisfy this sine a square plus cos a square is equal to 1. So now we got this equation. So now we have a common term, square root of 1 square plus 0.5774 square, that we can take outside. So we will be getting this equation. So if we calculate the value, we will be getting 1.548. So here this value is 0.866 and this value is 0.5. So we got this equation as sin a cos b plus cos a sin b. If we find this square of these values, we will be getting this value 1. So we can directly compare this sin a is equal to 0.866 or cos a is equal to 0.5. Now we can find the value of a, that is sin inverse 0.866, which is 1.0472 radian or 60 degree. So now we know the value of a and b. So we can simplify the equation as c of t is equal to 1 minus e power minus 2.t into 1.548 into sine of 1.0472 plus 4.33t. So this is the simplified equation which is having exponential term and single sine term.